Okay, welcome back to chapter 4. So we have remaining 4.3 to perform mass balance calculation for multi-stage counter current flow system. So for your multiple stage, the difference is in terms of notation used for your inlet for your inlet solvents, and also your inlet solvent, and also your outlet raffinates. Okay, so in order for us to solve a problem related to multiple stage for LLE is the first thing is you need to know how to do the overall mass balance. So this is important because for the next step we are going to find the coordinate for M. So this is how we do. Usually we will take the inlet value because it's always given equal to M, and also then the mass balance for the component A and also the mass balance for the component B. So you need to solve all this calculation in order for you to determine your M coordinates. So next is, in order to determine the value for Ln V1 including of the flow rates and also coordinate, we need to do some step to follow. The first thing is you need to have the ternary diagram for the systems. Next, you calculate the M coordinate using the stated balance is equation 3.2, 3.3, and then you put locate your M coordinate on your graph diagram. And next is you need to locate the coordinate Vm plus 1 and L0 because it will be given in this case. And usually for multiple stage, there will be given you the SAN for your raffinates. So coordinates of Vm plus 1 and Ln must lie on the face envelopes of the boundary. So normally normally SAN compositions of solute at raffinate will be given. Okay, next is you are going to connect the line Ln to M to obtain your V1. So this is how you get the value for your V1. So make sure your V1 must lie on the face boundary. Next, you can calculate the Ln and V1 using the equations. Okay, so let us see the example okay, so we will see how the step the determinations of number of the theoretical stage. So for your LLE, you must have the graph diagram for the given questions. Okay, so for this exercise, you just use the diagram that you have been plotted previously on the graph paper. So in order for you to determine the number of theoretical stage, first you need to find a reference coordinate. So how we get our reference coordinate is through the connection between the line of L0 and V1 and Ln and Vm plus 1, which must touch each other at the ends. So it will give you the line, it will give you, so I'm going to erase first. So this line will meet at the end point. So this is how we put the reference point. Okay, so next is you need to start iteration from V1 to equilibrium diagram, then back to ternary diagram to give you L1 coordinates. And then this step is proceeds until you get your final L to your Ln. So how we calculate the stages? If we have one line for V1 and L1, we calculate one stage. We continue L2, V2, second stage. Okay, continue the same procedure until the line intercept the final operating line, or as I said earlier, your value for ln lah. You get the value for your ln. Finally, calculate the quantity of the line in the diagram which represent the number of theoretical stage. So as I said earlier, so how you calculate the stages is L1, V1, 1 stage, L2, V2, 2 stage. This is for complete stage. If you don't have the complete stage, you cannot calculate it as one. Okay, for example, for this exercise, so let us read the questions. An aqueous fits of 200 kg per hour containing 40 weight percent of acetic acid. So this question you know for your feed 200, so your L naught, and this is your L naught and XAN. This is your L naught and XAN. It's being extracted by pure isopropyl ether. So it is given here pure isopropyl ether. That means you have the value of A at your V. You have the value of A at your Vm plus 1. At the rates of 600 kg per hour in a concurrent multi-stage system, so you know this is multiple stage, the acetic acid concentration in the aqueous phase contains 10 weight percent. That means it is given you XAM value. The equivalent data is provided in the appendix. Question number 1, sketch the schematic diagram. You need to sketch the diagram, just give you what is in. So must be a complete diagram, so must be label your L notes and also all the compositions. And next, construct the diagram, so plot the graph as you plot on previous exercise. So next, the composition of extract acid and raffinate. So you need to find your Ln and also V1 coordinates. So the amount of extract and raffinate, so you need to do balance calculation, and then percentage of acetic acid being removed in minus out over in for A times 100. The number of liquid stage must be calculated from the graph. Okay, the step is we have 10 steps. First, plot the ternary diagram of the system. Locate the coordinate. So this coordinate must have all the information. If not, you cannot plot in your graph. So this is the step. Next, M coordinate. So you need to do balance to find the M coordinate. Next is you are connecting Ln. Since we have the value for Ln, connects to M, so you will obtain your V1 coordinates. So after that, you need to Ln to M, so you get the Ln to M, you will get the M, so it's located in the intersections of Ln M with the phase boundary. So line L naught, V1 and Ln plus 1 are drawn. The intersections is the operating line. So you need to connect between your L naught, V1 and Ln Vn plus 1. So you connect this line. Okay, find V1 and L1 using 45 line or tie line. Okay, so line L1 is next drawn to locating L1 is next drawn to locating V2, V2 find L2, L2 find V3. Stop where you. So make sure your final L must be over your Ln or touch your Ln. So I think you cannot see this step, so we go for the graph. So this is the graph. The first step is you need to draw to locate your L naught, your Vm plus 1, and also your M and Ln. So make sure the mistake that had been done by student is they're putting the Ln on this line. Cannot. It must touch your boundary. So after you have this coordinate, so M is from the balance, so you need to connect your ln to m until top face boundary, so you will get your V1. So this is how you make a reference point. So you need to touch between L0 V1 and Ln Vn plus 1 to get the reference point. After that, you take your V1 here to the bottom, touch the equilibrium to the top. So you will get your L1 here. So this is complete state of V1 and L1, so one stage. So next, L1 must be using a ruler. So use your ruler. Okay, how to make it move? Okay, so using your ruler, make sure your L1 meet the reference point, and then this is where you can read your V2 here. So V2, the same process. So take the V2 to the bottom, sorry, cannot have a straight line, to the top, and you get L2 to the reference, and then read until your L must be touch your Ln or over your Ln. So it must be around here. If not, you need to proceed until you reach that point. So then this is next you can calculate your stages lah. So L1 V1 1, L2 V2 2, and so on. This is how we calculate the stages. Okay, I think that's all. Thank you.